Hello class, in this video I'll be showing you how to solve a related rates problem. Let's begin. A 25-foot ladder is placed against a building. The base of the ladder is slipping away from the building at a rate of 3 feet per minute. Find the rate at which the top of the ladder is sliding down the building when the bottom of the ladder is 7 feet from the base of the building. To begin this problem, I'm going to draw a picture to help identify some of the quantities. In this picture, we have a green ladder that is leaning against a wall. X will be the horizontal distance from the base of the ladder to the wall. Y is the vertical distance from the top of the ladder to the floor. Z is the length of the ladder. We can identify two more quantities from the problem. The first quantity is the base of the ladder slipping away from the building. This represents a change in the horizontal distance, which is measured by a derivative. We'll call that derivative dx dt, where t is minutes. The second quantity is the rate at which the top of the ladder is sliding down the building. This is a change in the vertical distance, which is also represented by a derivative, which we will call dy dt. The other quantity we will need is dz dt, which is the change in the length of the ladder. Now that we have all the quantities, what is the problem asking us to find? The problem is asking us to find dy dt given x is equal to 7, z is equal to 25, dx dt is equal to 3, and we don't know the values of y or dz dt. However, we will calculate those values later on in the problem. To find dy dt, we need to create an equation that relates the three variables x, y, and z. Since the floor is perpendicular to the wall, the ladder acts like the hypotenuse of a right triangle. So we can use Pythagorean theorem to find dy dt. Now we will take the derivative of each term with respect to t. That will look like this. To make the equation easier to work with, I will divide every term by 2. That will look like this. Now we are ready to substitute the given information into the equation. We know that x is equal to 7, z is equal to 25, and dx dt is equal to 3. After making those substitutions, the equation will look like this. We are trying to find dy dt. However, we do not have values for y or dz dt, so we are going to calculate those now. I will start with dz dt. That is equal to 0 because the length of the ladder never changes. And solving for y is pretty easy. We're just going to use the Pythagorean theorem. We know that x is 7 and z is 25. So we have 7 squared plus y squared is equal to 25 squared. This means that y squared is equal to 576. So y is equal to plus or minus 24. Since y represents a side length, we can discard the negative 24. So y is equal to 24. Now I'm going to substitute the additional information into the equation. That will look like this. 25 times 0 is 0. So we have dy dt is equal to negative 21/24. And this is equal to negative 0.875. This means the ladder is sliding down the wall at a rate of 0.875 feet per minute. And we are done.